So in this video, I'm going to be doing problem 2 from test 1 in spring 2020. So here it's similar to problem 1, except we don't have one number, we have multiple numbers like this. Okay, so the idea here is 3 is present in at least one of those. In fact, it's present in both. And 4 is present in at least one. Specifically, it's present in the second vector. So because both 3 and 4 are present in at least one, we can say that all of the elements of nums are present in at least one. So we get to return true. Okay, so each entry in nums should be present in at least one of vec1 and vec2. So there's actually several approaches here. So let me just quickly say this is problem 1. So the approach that I'll take is to use this function since we already have it and use it with sapply. So the name of the function here is present in at least one vex, like this. This function, we'll say nums, we'll say vec1, and we'll say vec2. So what I'm going to do now is I'm going to use sapply in order to apply present in at least one to every element of nums. So I'll say sapply and I'll say x is equal to nums. So for every element in nums, we'll apply the function present in at least one. And we'll also send along vec1 and vec2. So we could be nice about it and say vec1 is vec1, so this means that vec1 here goes here, vec2 here goes here, so I'll also say vec2 is equal to vec2. So this would give me presences, so I'll call it like presences. So it's going to be true if the first element of nums is present in at least one. It's going to be the second element of presences is going to be true if the second element of nums is present in at least one, and so on. So let me just quickly run it. So let's say that, so I'll do the example from the test handout. So vec1 is going to be C123, close this bracket. Vec2 is going to be C3654, and now I'll set nums to be 3 and 4. Okay, so if I run this, what I'll get is true and true. Now, if nums had an element which was not present in any of those, either of those vectors, vec1 and vec2, then one of those would be false. So there are several ways of kind of trying to make sure that what we want to do is we want to make sure that all of those are true. So one possible trick is to say we'll do sum of presences, and that should be the length, the same as the length of nums, right? So the trick here is we have two numbers, 3 and 4, and we have presence, so true, true, and so on. So if you sum those up and you get the same number as the length of nums, that means that all of those were true. So another possibility, and that might be kind of more intuitive, is to say mean of presences is equal to 1. So that means that there are no falses there, because the only way that it would be true is if all of them are, if all the presences are true, trues correspond to 1, falses correspond to 0, remember. So okay, so we can do it like that. So we should probably test it. So here I already defined some, well, let me just define it from scratch. So I'll say nums is 3, 4, and I'll say vec1 is C123, and I'll say vec2 is C3654, like this. And now I can call this function, so present in at least one vex, and I'll say nums, and I'll say vec1, and I'll say vec2. And that's supposed to be true because 3 is present in both, and 4 is present in this one, right? So this is supposed to be true, and indeed it is true. So in order to set it up so that it's false, maybe we'll do like 7. 7 is not present in either of those. So I'll just copy and paste this so that we have a new example. So this is supposed to be false once I set this to 7, because 7 is not present in either one, right? So do that, and that indeed evaluates.